Gerald poured 30.8 liters of water into two empty containers, X and Y, without any flowing, and without overflowing. So only X was completely filled and it contained 10 times as much water as container Y. How many liters of water did Gerald pour into container X, container Y? Okay, so this one will be quite simple because 10x, container X was completely filled and it contained 10 times as much water as container Y, right? So we can just draw the model for this one. Okay, wait. Let's just draw the model for X. Is 10 times, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for Y, it will just contain 1 unit of water. And total, we know that it is 30.8 liters of water. Now, so for this one, how many liters of water did Gerald pour into Y? So this will be quite simple because 11 unit will represent the 30.8 liter, right? Because over here there are 11 units. Okay, so for container Y is just 1 unit. So let's just find 1 unit. So let's just throw that into the calculator. 30.8 divided by 11. And that will give us 2.8 liters. Okay, so the first part over here, this one will be 2.8 liters of water. So this one is part A. Part A is done. Okay, now wait, let me just change the, okay, so should be clearer. Now, the next part, they actually mentioned that the ratio of the total capacity of X to the total capacity of Y is 5:8. How much more water was needed to fill Y completely? At this point of time, because X is totally filled with water, so we can find out, from this model, we can find out how much water is there in container X. Okay, since container X is 10 units, right? So we have 1 unit over here. So 10 unit will be 10 multiplied by 2.8 liters. And that will give us 28 liters. Sorry, in the working there is no need for any units. Now, they mentioned that the ratio of the total capacity of X to Y is 5:8. Since X is to Y will be 5:8, which means right now 5 unit will represent the total capacity of X, which is 28 liters. So we have to find 8 unit to find out the total capacity of Y first. After we find out the total capacity of Y, we will take the total capacity of Y minus the water that is really inside Y to find out how much more water is needed to fill Y completely. So we find 8 units. 8 units will be 28 divided by 5 multiplied by 8. So 28 divided by 5 multiplied by 8, and that will give us 28 multiplied by 5 divided by 8. That will give us 17.5 liters. So the total capacity of wait, why is it so little? That doesn't make sense. Wait, 28 divided by 5 multiplied by 8. Sorry, this is wrong. I input the wrong figure. So it's 44.8 liters. Okay, so just now, right, why do I immediately realize that this one has something wrong? It's because if 5 unit is 28, how can my 8 units become 17.5? It's even lesser, right? So this is actually how you need to check your own working as well. It's via logic. Once the logic doesn't make sense, right, you need to recheck your answer. Okay, not everything you just blindly follow the figures over there. Now, so we know that the total capacity of Y is 44.8 and then it has 2.8 liters of water inside. So how much more water is needed to fill up Y completely? So we just take 44.8 minus 2.8 liters. So 44.8 minus 2.8, that will give us 42 liters. So that will be your final answer for this one. So for questions like this, it actually incorporates a couple of topics, like for example ratio. It incorporates model drawing as well. So for all this kind of stuff, you need to ensure that your other topics, they are quite good first. I mean, like, at least you're quite competent in other topics before you start doing this kind of stuff. Which is why for this one, it's actually considered as chapter 10. Yeah, it's actually topic number 10. So before you move on to topic number 10, please ensure that your topic 1 to 9, it is on par before you can even try this type of question. Alright, done.